All right, so here is the beginning of organic. Now, like I said, the honors class that you're in is primarily inorganic chemistry. So this is just a very little section of organic. If you're going to go into most sciences, if you're going to go into some different kinds of engineering or in health, you'll definitely probably take organic in college. And it's typically at least one semester, typically two, or you take two classes and two labs. So it's much bigger than what we're going over, but this is kind of just to give you some background in it. And then that way, if you get to college and you're taking it, you have a couple days where you're like, I know what they're talking about, before it gets really difficult. So the major thing that if you're organic, you're going to contain carbon atoms, and you're going to have a lot of carbon atoms, and we're talking chains and chains and chains and chains of carbon atoms. And it's kind of interesting because carbon is really the only element that's able to do what we need it to do to make these carbon chains. Not everything that just because it has carbon in it is considered organic. So like carbon monoxide is not considered organic. Carbon dioxide is not considered organic. And like carbonates, bicarbonates, they're not considered organic. We're really talking about like lines of carbons. So the formal definition is that it's going to be covalent. So we talked about covalent bonds already. And they're going to include the carbons, and they're going to exclude carbonates and the oxides. And then these are just some examples that you have heard of before. So we know aspirin, if you get plastic bags at like Walmart or Giant, citric acid in your fruit, and your amino acids, which make up your DNA. And the thing that makes carbon so special is this word right here. So you probably want to underline it or highlight it or something, because this is what makes carbon have its strange ability. So it's called catenation, and it's the ability of carbon to just continually forming bonds with itself over and over and over. So most things can maybe form with one other of the element, two of the other of the elements. Carbon basically has a never-ending supply. Like you can make a carbon chain as long as you want, and as long as you don't break it, it can keep going. And not any other element can really do it. Sulfur can do it to a very small amount. Arsenic, I think, can do it a little bit, but you can see it's kind of why are we carbon-based life forms? Well, because it has this ability. So we said before that carbon can bond to itself, and it can also bond to other elements. So what we're going to look at most of it is we're going to look at hydrocarbons, and that's what we're going to be looking at today. And basically, they're exactly what they sound like. You have just hydrogen and just carbon, and they're going to be your simplest ones. So we're going to focus on, okay, how do they form? How do we name them? Because they have a very unique naming system. And then we'll look at some of the other weirdo ones later. So carbon can bond to other things. A lot of times it bonds to oxygen. It can bond to nitrogen. It can bond to sulfur, and some other elements here. So it can happen. It's just not that common. We're going to focus on kind of how do you do hydrocarbons. And then we're also going to focus on how can you identify the other types. We're not going to go in any more depth than that for this. So what we're going to focus on right now is just how do you name and write them. So there's two types of hydrocarbons. You have saturated hydrocarbons, and those are basically ones where you only have single bonds. So what carbon looks like, just draw. Carbon is you have your little C, and then you can think of carbon as having like four little lines off of it, one on each side, and that represents a bond. And what that means is that carbon can form four bonds. And if you have a single bond, that's drawn by a single line. So if you're a saturated hydrocarbon, every single one of your carbons is going to look like this. It's going to be a carbon, and it's going to be attached to things, like at the end here, but they're all going to be single. What you won't see is something like this. Like you won't see a carbon double bonded to something else. So this would not be saturated because that's it has a double bond or a triple bond. And when we say saturated, what we're actually talking about is we mean saturated with hydrogens. And when you're saturated, you have the most hydrogens that you possibly can. So there's no other elements. It's just hydrogen and carbon, and they're all single bonds. So what we're going to do is kind of go over how you name alkanes, and then we're going to actually practice them on the next one. So this is a short one. All right, so there's steps to naming them. and we're just going to follow the steps, and then once you follow the steps, it makes sense. So the first thing we're going to look at today is alkanes. If you understand how to name alkanes, the other ones are not that difficult. If you don't understand how to name alkanes, just gets more complicated from here. So try and really focus on these today. So what we're going to see is the ending here is giving you hint. So if it ends with ane, that means you only have single bonds. And there's all these little like hints and clues that mean something. And we have the International Union of Physical and Analytical Chemists, that's UPAC, and they're the ones that came up with this. So the very first step you have to do is you have to find the longest chain of carbons, and that means a continuous chain. Now be careful because, we usually think of chains that go like this or chains that go like this, but organic compounds fold and they change shape. So sometimes the longest chain could be going straight across, and then it might kind of turn, and that could be the longest chain. So you have to look for the longest continuous chain of carbons as your first step. If you mess up this step, the rest of your whole name is wrong, and you'll have wasted all that time. So, say you find your longest chain and it's 6 carbons. What you do is you look up 6 on your chart, which is hex, and then since today we're dealing with just hydrocarbons, the saturated ones, they're going to end in ane. So what it would be called is hexane, etc., etc. And this will make more sense when we do them. You just have to make sure that you kind of get the steps down. Second thing you're going to do is you're going to number your carbon chain, and you're going to number it towards the end. It has the first branch, and that just means something hanging off of it, not a hydrogen, but like another carbon or something. It says if there's branching at equal distance, then you do the first one with the alphabetical order. And then if you have things hanging off of it, what you do is you actually follow this naming. So this guy right here, you would have like a big carbon chain. I'm just drawing a line for that. And then off of it, you would have 1 carbon. And that would be representing a methyl group. And what you're going to notice is there's hydrogens everywhere. And a lot of times, it's not that we don't care about the hydrogens. It's not that the hydrogens aren't important. But we kind of leave them off so that it's not as cluttered, because it can get a little cluttered here. What I do want you to do is write down 2 weirdos for the branches. If this is 1 carbon, this is methyl. If you have 2 carbons, you're ethyl. If you have 3 carbons, you're propyl. And if you have 4 carbons, you're butyl. And I just want to show you 2 other weird ones that we have. The first one is if we have a nice long carbon chain here. So just imagine this line is a carbon chain. Now this one's a little different because most carbon chains that hang off of things are perpendicular. But if you look at this one, he is parallel. And what he's called is, if you count this, this is 1, 2, 3 carbons. And that looks like propyl. But if you see here, he's not attached on the end. He's attached on the second carbon. So what he is called is he is isopropyl. So that's one weirdo. And then the other weirdo, if I have a nice long chain of carbons, is called T-butyl. And he can look a couple different ways, but the primary thing is that there's 4 carbons, because that's what butyl means. And the last thing for him is he looks like a T. So he looks physically like a T coming off. And we call him a T-butyl. If there's more than one of these groups, then we're going to have to use prefixes to let them know it. The thing with organic is the naming is completely redundant. Like, it overemphasizes things so there can be no confusion. So if I have 2 methyls, I actually tell people that there's 2 methyls. I would say dimethyl. If I had 3 methyls, I would say trimethyl. So you actually tell them how many of each thing you have. And then when you're all done, you write it out as a single word, which we'll work on. So what we're going to do now is, the next video is actually doing the naming and going through and doing each of them.